Flutter Bloc provides the function to observe what is happening in Qubit or Bloc. As the version of Flutter Bloc was upgraded to 8.1, the way Qubit or Bloc is observed has changed. The Bloc Overrides API introduced in version 8.0 has been deprecated, and the Bloc.Observer and the Bloc.Transformer APIs used in version 7 have been reintroduced. The Bloc Overrides API was introduced in version 8.0 in an attempt to support the scoping block-specific configurations such as Bloc Observer and Event Transformer. In pure Dart applications, the changes worked well. However, in Flutter applications, the new API caused more problems than it solved. In addition to problems such as deeper nesting and increased code amount, it caused problems such as requiring a deep understanding of the zone, which is a significant hurdle for beginners. Also, since Flutter does a lot of work behind the scene when invoking or forking zones, it can exhibit unexpected behavior that is out of the developer's control. So, the author decided to deprecate the Bloc Overrides API and introduce the Bloc.Observer and Bloc.Transformer APIs again. For details, please refer to the link below. This is a picture of a qubit from the README file of the Flutter Bloc package on pub.dev. State changes in qubit are triggered by the emit function. At this time, before the actual state change occurs, the qubit's change event occurs and the onChange function is called. When outputting change, the current state value and next state value are output together with the change event. Next is Bloc. State change in Bloc occurs when an event is added, and the onEvent function is triggered at this time. The event then goes through an event transformer. Basically, an event transformer is used to apply the necessary manipulations to the incoming event stream. The event transformer is covered later. The event that has passed through the event transformer is processed in the corresponding event handler, and a new state is generated by calling emit in the event handler. Before the actual state change occurs, the Bloc's transition event occurs and the onTransition function is called. This transition event consists of the current state, the event that triggers the state change, and the next state. The process from when the state change is triggered until the state change occurs in the UI is as shown in the figure. Create event occurs when Qubit or Bloc is first created. When the next event occurs, the onEvent function is called, and when a transition event occurs next, the onTransition function is called. And just before the state change is reflected, a change event occurs, and the onChange function is called at this time. Finally, when Qubit or Bloc is no longer needed, the close event is generated, and the onClose function is called. Here, from event to change, it occurs repeatedly until it is closed. Here, C is Qubit and B is Bloc, and you can see that create, change, and close occur in Qubit. In Bloc, event and transition occur in addition to Qubit's create, change, and close. So you can get additional information about the event that triggered the state change. In other words, in the case of Bloc, we can say that the cause that triggered the state change can be traced. In the case of Qubit, you can know the change in the state value in change, but you cannot know what triggered the state change. This feature is useful when the result of state change is the same, but the cause can be different. For example, consider a case where a user is logged out and the authentication state is unauthenticated. A user can log out for several reasons. The user may have pressed the logout button, or he may have been automatically logged out due to a timeout. In this case, Bloc has the advantage of being able to trace the cause. In addition, Qubit and Bloc provide the add error method. If you call add error, when an error occurs in Qubit or Bloc, the onError function is called, so you can handle the necessary error here. And this onEvent, onTransition, and onChange can be used in Qubit or Bloc units or in app units. When used in the app unit, create a subclass that extends the Bloc Observer class provided by Flutter Bloc and override onEvent, onTransition, onChange, etc. Next, assign a subclass that extends the Bloc Observer to the observer property of Bloc. The difference from processing in Qubit or Bloc units is that an argument of Bloc base or Bloc type is added because you need to know which Qubit or Bloc the event occurred. Block-based type arguments are added to onCreate, onClose, onChange, and onError, which are commonly applied to Qubit and Bloc. And block type arguments are added to onTransition and onEvent, which are applied only to Bloc. And when onChange is overridden in Bloc, and onChange is also overridden in Bloc Observer, onChange of block is executed first, and then onChanges of block observer is executed. Then let's apply block observer to the block app we created. In the example, we will create a class that extends block observer and test only applying it in app unit. Observing a function such as onChange on an individual qubit or block is a relatively simple task. All you need to do is to override the individual function. Let's start by creating a block-to-block observer 81 app and copying the block-to-block app. However, there are some differences from the previous block-to-block app. The first is the package version. The Flutter Bloc version used this time is 8.1.1 and the executable version is 2.0.5. The second is the analysis options.yaml file. In the past, the entire include line was commented out, but this time the include line was left as is and the avoid print line was uncommented. This is to prevent the lint warning displayed when the print function is used in the app. The third is that constant modifiers are applied when necessary to eliminate the lint warnings that are displayed according to the application of the basic lint rule. First, I will create the observer folder under the lib folder and create app-block-observer.dot file under the observer folder. If you type block observer under VS Code and hit enter, a template called myBlockObserver is created. I will change the name to app-block-observer. 4 functions are created in this template: onEvent, onError, onChange, and onTransition. If you look closely at the created functions, they all have an argument called block. However, the type of the block argument of onError and onChange is block-based, and the type of the block argument of onEvent and onTransition is block. Why is this? onError and onChange are common to Qubit and Bloc. However, both Qubit and Bloc are classes that extend the block base. Therefore, onError and onChange have arguments of block-based type. On the other hand, onEvent and onTransition are all in block, not in Qubit. That's why the type is block. An additional argument other than the block argument is an object corresponding to each event and has additional data about the event. In the to-do of each function, I will insert the code that outputs the event handler's name, the block's runtime type, and the object passed as an additional argument. For error, there is one more stack trace argument. It's a simple print repetition. So I'll make a code and come back. If you look, these are print statements that print the runtime type of block, an additional object after prepending event handler name. So now let's go to main.dot and work on making the app-block-observer available. Assign an app-block-observer instance to block.observer before calling the run app function. I ran the emulator for test. Let's click the change color button. You can see that onEvent, onTransition, and onChange are printed to the console in the order. If you look at onEvent, the type of block where the event occurred, and the change color event instance, which is the event that triggered the onEvent, are displayed. Similarly, detailed information has been output to onTransition and onChange. After clearing the console, let's press the increment counter button this time. For counter block, you can see that onEvent, onTransition, and onChange are output in order. Block Observer is very useful for debugging because you can track state changes and their causes. With this, we learned about Block Observer.